Okay, you have vibe coded your application. You are not a software engineer. Not yet. You have just discovered fire. You are not a nuclear physicist. What distinguishes software engineers from rookie application coders are the design decisions they take while building their applications. And today we'll be talking about one very important design decision you should take into consideration while building and or launching your application. This design decision is called sharding, or others will call it partitioning. What happens when your user base grows and your data grows to an extent that one machine can no longer handle it? You must replicate and partition. What is partitioning? Partitioning is the process of breaking down your data into chunks and distributing this data across multiple nodes so that one single machine does not handle everything and the workload is dispersed across multiple nodes. Partitioning happens in two types. The first type of partitioning is logical partitioning, and the second is physical partitioning. The logical partitioning happens in design time, and it covers things like separating the user data from product data or other data. And the physical partitioning happens on the machines itself, where we separate data into chunks across multiple machines. And with this, we use certain algorithms or key matching pairs to distribute the data efficiently across these machines. Partitioning has certain advantages that are very vital in designing a system. This could make or break your application depending on how you handle the design. For logical partitioning, we have a few options to pick from. One option is functional partitioning or geographic partitioning. This happens when we segment data across regions so that different people living in different regions see different types of data. Another is vertical partitioning, where a table is divided into different columns, and this this is the general design decisions that we take when modeling data. So we have the user table, we have the product table, then we have other table. So the split in these models determine what data goes into what table. We have another example called tenant-based partitioning. This is very crucial in B2B businesses when building an application for organizations, and different organizations are living on your platform. So you have to have a way to segment this data so that other other companies don't accidentally look at other companies' data. So in terms of physical partitioning, we have a few options based on the algorithms that are used in retrieval of or deposition of data. So we have key range partitioning, where this is very vital in certain applications like time series applications, where the data comes in time series, right? So in this key range partition, you have something uh, like in this type of partitioning, you have something like the weather stations data, right? And this weather stations data comes in seasons, and due to these seasons that the data comes, we have to segment the data based on this season. So a month of January will have its segment, a month of March will have its segment, a month of April will have its segment. So this is how the range-based partitioning works in the physical partitioner. And we also have the hash partitioning, where we use a hash function to hash the keys, such as the user ID, we hash it, then we evenly distribute it across nodes. This has some slight advantages and some disadvantages. The advantage is that the data is evenly distributed across nodes, but the disadvantage comes in when you want to take a range of data, and also it is more prone when you want to take a range of data, right? You would have to be hopping from one machine to the other in order to get the range of data that you want. And this is the disadvantage of hashing. But the key advantage is, as I said, even distribution of data across nodes to prevent issues such as hotspots. Key range Key range partitioning is prone to an issue such as hotspots. It distributes data across in ranges, so it is easier to grab ranges. But in terms of hotspots, it is prone to this problem. What are hotspots? Hotspots are when data compounds on one machine unevenly than other machines. So you have this particular machine which has so much data, and other machines are empty, right? This is a hotspot. It comes when the key is not, the algorithm for distribution of data is not set properly, and or you are using key range partitioning where the data comes in seasons and therefore is prone to this. So, for example, a weather station, if let's say the month of March has more rain than the month of uh, January, then you see that that particular month data grows significantly than the data in January, right? Then we have consistent hashing, which is another form of hashing. Consistent hashing is unique in a sense that we have we use a clever technique to solve the problem of hashing, right? It's a sweet spot we get in hashing where we have an arbitrary circle, right? We draw an arbitrary circle, and in this circle we put the machines that we have available, right, clockwise. So we put them clockwise in an imaginary circle, and we use the angles, right, to calculate where the data goes. So we have machines distributed across a particular ring, right? Then what we do is that we start distributing data across them, and when one particular node so we start distributing data clockwise, right? So when one particular node gets filled, we rebalance it by taking this half of that data in that node and distributing it in the next node in the imaginary ring, right? Therefore, constantly, what happens is that the data is set in a way that the is set in the way that rebalancing doesn't cost us so much money, because rebalancing it only takes probably one one transfer away, right, to rebalance the data. So as data comes in, we distribute them across nodes, and if one gets significantly more data than the other, we take half of that and we put it in the next, which is in the ring, in the imaginary ring that we have drawn. So that is how consistent hashing works. And I think this is gaining adoption, and it is prevalent in the industry because it's much more, it solves issues such as taking data in a range, right? Because in this case, we are able to retrieve data in a range in the imaginary ring that we have drawn, right? And also, it prevents issues such as hotspots, because data is approximately evenly distributed across nodes, and also makes it so that data is not randomly dispersed, right? We know where what range of data is at a particular point in time in that imaginary circle. So I would say consistent hashing has, if I were to rank them, I'll put consistent hashing number one, then I will put hashing and key range. It depends on which it depends on which it depends on what you are using it for. But if you are going to use hashing, you might as well use consistent hashing. And if you are going to use key range partitioning, then you should use it for cases such as partitioning time series data in your database. So to recap on everything that I just talked about, if you are going to handle the load of your database, you need to first logically, this is a design time decision. You need to first logically partition your data, whether you're going to use functional partitioning or vertical partitioning or multi-tenant partitioning, right? You will do that. when designing the application. Then as your data grows, I say this because for the logical partitioning, usually it doesn't change that frequently. So as your data grows, then you tend more to partitioning your data uh, physically, right? And with this, you have options to choose from what type of partition methods that you are going to use, right? If you are going to partition your data by if you're going to partition your data by key range partition, then you have to be aware about certain issues such as hotspots because key range partition is prone to that. But the advantage is that you can take data in a range, right? And also, if you are going to take hashing, if you are going to take hashing, or you're going to if you are going to partition your data by hashing, then you should be aware about the difficulty that comes in fetching range data, right? But it gives you the benefit that the data gets distributed evenly. And if you want to take one that fits both, I would say go for consistent hashing, but you would have to face the difficulty in the algorithm that you use in creating your imaginary ring. I would hope that is standardized. It's an industry algorithm, therefore you wouldn't have to reinvent it. But yeah, that algorithm, consistent hashing, enables you to have the best of both worlds. You can partition your database in a range and also evenly distribute them. And also one benefit that comes with it is the low cost of rebalancing data, right? When there is a hotspot, the cost of rebalancing data is cheap because it is just one node away from transferring data, right? So that is how partitioning works in general. When your application begins to gain more followers and your application begins to accumulate more data and your database is getting full, this is one thing you should take into consideration by replicating and partitioning your database to ensure that your application is able to handle user demand. So I'll end this here. Thank you again for listening to this video. I'll catch you next time. Peace.